Hey everybody. Today we're talking a little bit about sets, because if you're going to be studying probability, you're going to be running into sets all the time. In particular, the sample space of a probability experiment is the set of all possible outcomes, and an event is a subset of the sample space. Let's start out with some notation. First of all, the empty set, that sort of zero with the line through it, is the set that doesn't have any elements in it. Conversely, capital S, the universal set, is the set of all possible elements, which in probability almost always means the sample space. Finally, the complement event of an event A, denoted A prime, is the set of all elements in the sample space, the universal set S, that are not in A. We deal with relationships between sets all the time. We call the sets A and B. A subset B, A contained in B, means that every element in A is also an element of B. A intersect B, the intersection of A and B, is the set of all elements that are in both A and B. And A union B is the set of all elements that are in either A or B or both. Notice here that the or is non-exclusive. The words or both really could be underlined here. We often use Venn diagrams to illustrate concepts in set theory and therefore also in probability theory. So here's A intersect B and here's A union B. There are lots of identities that come up when you're working with sets, the two most important of which are De Morgan's laws. A union B complement is A complement intersect B complement, and A intersect B complement is A complement union B complement. You should try drawing Venn diagrams for both of these. I'm going to show the first one on the next slide. So here it is. On the left side of this equality, you should imagine the thing in parentheses as being the unshaded region in this illustration, so A union B. So the shaded region is the complement of that. On the right-hand side, we are talking about all elements that are not in A and are also not in B. So again, that's the shaded region in this diagram. Now there are a ton of other identities that I could list here and you'd forget them. I forget them all the time. Here are the two most important ones, the distributive identities, in case you need to refer back to them later. And you can think of these as being akin to the distributive identities when you're just talking about arithmetic or algebra by looking at the left-hand side of these equalities and imagining the cup or cap inside the parentheses as being a plus, and then the other cup or cap outside the parentheses as being a times. So like A times B plus C is A times B plus A times C.